180, can it be divided by any one of these perfect squares? So let's go back here. Excuse me. We have 25, we have 36, we have 49, and so on. Well, 180 divided by 4. What's 180 divided by 4? Let's get a calculator. Is that possible? 180 divided by 4. And yes, if you do that correctly, you get 45. Now hold on. I can stop at 4. Or I can try to see if there's a bigger number I can divide it by, a bigger factor. What's 180 divided by 9? Well, yeah, that works as well. That's 20. Do you want to try 16? Let's see if that works. Oops, it is 180 divided by 16. And no, 16 doesn't work because it gives us a decimal value. What about 25? 25 doesn't work because it gives us a decimal value as well. So we can stop at 9 if you want, and then try to do it, or we can continue dividing bigger numbers to see if any of the other bigger ones work. It doesn't really matter. I'm going to show you both ways of doing this. So let's say we take the 9 as a factor. So this becomes square root 9 times 20. Hopefully everyone can agree that 9 times 20 is 180, so I didn't really change the value. This becomes square root 9, square root 20. And we know that square root 9 is just 3, whole number 3, and square root 20. Now square root 20, can 20 be simplified further? Is 20 as simplified as possible? Let's find out. Can I do 20 divided by 1? Well, obviously 1 doesn't change anything, but can I do 20 divided by 4? 20 divided by 4, and we'll give you a value of 5. So yes, I can simplify 20 further. So this will become 3. Remember, the 3 is just always in front now. Square root 4 times 5. If I do that correctly, this becomes 3 times square root 4 times square root 5. If you don't know, this circular dot is another symbol for multiplication. So you can have an X, or you can have a dot, or you can have two brackets next to each other like this, which hopefully you remember from grade 10 and FOIL and whatnot. The brackets next to each other are also a form of multiplication. So just different ways of doing the same thing. So we know that 3 is just there. And you know square root 4 becomes whole number 2, not square root 2. A lot of students make that mistake. And this doesn't change. So the answer is now, what's 3 times 2? It is 6 root 5. And that's the final answer. Because we cannot simplify square root 5 any further. Now, what if I were to find an even bigger number that 180 can be divided by? Because if I had to simplify 20, even after taking out a factor, that means there's one factor that I could have done from the very beginning, and that will be here. That number, I believe, is 36. What's 180 divided by 36? It's 5. That means I could have just done root 36 times 5, and I know that root 36 is just, whole number 6, and that's the answer. So I wanted to show you both techniques. Why? Because some students, you may not always get the largest factor, and that's okay. You can take a smaller factor, but you just realize that you'll have another step to take out and simplify your resultant answer. Whereas in this case, if you take the largest factor possible, then you can't really simplify square root 5. That's it. So yeah, that's radicals. Let's continue. Here we're going to learn about adding and subtracting radicals. So adding and subtracting radicals works the same way, just like if you're adding and subtracting polynomials. So you can only add or subtract like terms, or in this case, like radicals. And what do I mean by like radicals? Well, here, let's do some examples, shall we? Okay, so we have 9 root 7 minus 3 root 7. So in this case, the number inside the roots the roots are the same. So they're both 7. In this case, this is an example of like radicals. Since the radicals are exactly the same, we can just add and subtract the whole numbers. So we just do 9 minus 3, which is 6 root 7. Just like if this was 9x minus 3x, this would be 6x, right? Just like that. Instead of x, though, we are now having a radical. So that is the first example. Let's move on to the next one. Here we have radicals, but look at the numbers inside. They are different. But if you look closely, are they really different? And what do I mean by that? Because clearly you'd be like, hey, one's 3, one's 27. But remember, we learned how to simplify radicals, right? If you have a really large radical, we can simplify, we can reduce it. So the first step is to always take any large radical and simplify it into a smaller number. So 27, can 27 be divided by any one of these perfect squares? Well, remember, 1 doesn't do much. 27 divided by 4, nope, that's going to give me a decimal. What about 27 divided by 9? And yes, 27 divided by 9 does give me a nice whole number, 3. So I have 4 root 3 minus 2 root 9 times 3. Remember, 9 times 3 is 27. I didn't change anything. And I have 4 root 3. And I'm showing every single step. You guys can skip a single step if you feel like you understand how to do this. But don't skip too many steps because you are required to show your work on tests and quizzes. So I would recommend actually not skipping any when it comes to tests and quizzes. But when it comes to, like, homework or practice, then that's fine. But for marks, you should definitely show your work. All right, so hopefully you can see that this becomes 2 times 3. 2 times 3 is 6, so this is 6 root 3. And the initial first term was 4 root 3. So now clearly you can see that the radicals are exactly the same. It's a trick question here. Radicals are exactly the same, so I can now add or subtract. In this case, it's subtraction. So what's 4 minus 6? And don't forget, you can have negative numbers, so that is negative 2 root 3. That is the final answer. All right, time to move on. Oh, what happened there? Let me try that one more time. Oh no. Okay. So, once again, here we have radicals that look different, but they're kind of large. So maybe we can simplify. Let's see, can we simplify 18? Can 18 be divided by 1, 4, 9, 16, 25? Can 18 be divided by any of these numbers? Well, 1, it doesn't do much. 18 divided by 4, nope, that's not a whole number. What about 18 divided by 9? Yes, we can do that. 3 root 9 times 2. What about 8? Can 8 be divided by any of these numbers? 8's kind of small, but we still have to check. And 8 divided by 1 doesn't do much, so there's really only 4. Can I do 8 divided by 4? And yes, you can do 8 divided by 4. And you will get an answer of 2. So the first term also simplifies to 4 times 2. And then we have a nice big plus sign between the two radicals. So this is 5 root 4 times 2, which is the same thing as 5 root 4 root 2 plus 3 root 9 root 2. And everyone should know that 5 times root 4 is the same thing as 5 times 2. Don't forget that root 2 there. And the same thing on this side here. 3 and root 9 is just 3. It's root 2. So 5 times 2 is 10 root 2. 3 times 3 is 9 root 2. So we've multiplied, and now we can add. And the radicals are exactly the same. As you can see, they're both root 2's. So the final answer is 19 square root 2. Here we have a nice big fun one. And we have fractions. Don't be fooled, fractions are just numbers. Just a little extra step. The first step is to always, actually, I'm going to, since I'm going to run out of space, I'll take this to a new page. All right, and enlarge it. No, let's make it a bit smaller. Okay, here we go.